But this time, instead of just counting how many people fall into each of those categories, let's add an outcome variable, and let's add a continuous outcome variable. So we're now going to look at gender and hair color on age at award. So we're going to ask, do men with light colored hair win at the same average age as men with dark colored hair, as women with light colored hair, as women with dark colored hair, as women with red hair? So we've got two predictor variables: gender, categorical, 2 levels; hair color, categorical, 3 levels. And then we've got a continuous outcome variable, age at award. When we have two predictor variables, we have 2 layers of questions that we are going to be asking. The first layer is asking if one predictor variable has an effect by itself. Do you remember these are called the main effects, a main effect of each of those variables by itself? The second layer that we will look at is asking if the 2 predictor variables combine together to have an effect, if they interact, or if they combine together in a linear or additive way. So we're going to start with a very similar contingency table. Let me go ahead and copy my data labels again. But instead of doing a count, we're going to, in each of these cells, calculate the average outcome, the average age. We're then going to look at the total of the rows and the totals of the columns and each of the 6 cells. Let's calculate those averages. In this cell here, we want the average of column F if column C is male and column G is light. We could do this by sorting, where we would sort and just get the males with light hair in a group and then average them. But Excel has a more foolproof way of doing it, where we're less likely to make human errors. We want a contingency and an average on contingencies, just like we just did a count with contingencies. And so just like the count ifs, Excel has exactly that same formula for average. Let's have a look and see if we can find it. So average if and average ifs, and then we want the plural one because we want average. So what's the range that we want average? We want age averaged. The criteria are that C is male and G is light. So that's the average age of males with light hair. Let's practice that again. We want average ifs. The outcome variable is that age at award. If C is male and click G and click. And what's this one? Oh, dark. Done. I forgot to click into the criteria range. Click. What's this one? Red. Excel's returned as an error. Hashtag div divided 0 exclamation point. Excel's trying to tell us that we can't divide by 0. We'll remove that in just a second. Let me just fill those down. And then edit them to be counting the females. I'm going to go ahead and delete that for the redhead males because there aren't any redhead males. All right, is that the data you got? We need to finish this contingency table with the overall averages. Instead of the total really implies sum. We're going to call that overall average. So we want the overall average for people with light hair, the overall average for people with dark hair, the overall average with people with red hair, and then here we want the overall average for the males and the overall average for the females. Can I average the averages? What do you think? Tell you what, let's do it right, and then we'll come back and see if we can average the averages. In this cell, we want to put the overall average of people with light hair. So let's use average if, average that range. Oh, they've got it differently, haven't they? So in this case, the range is referring to the criteria. Equals light, and then the average range is the outcome. So the overall average of people with light hair is 44 years old. Let's double check and prove to ourselves that we can't average averages. So if I just calculate the average of those two cells, I end up with a very different number. Do you remember why? You have to go back to the raw data when you're averaging. You can't assume that these are coming from the same sized groups. And indeed, we can see up here that they were not coming from the same sized groups. So averaging those averages, don't do it. If this equals dark, then average that. Not liking my... Oh, I see what I've done. Do you see what I did? I capitalized the K instead of having a shift for the quotation mark. If this is red, then average the age in years. If this, what's the criteria we want here? Right, we want male. Average the age. If this is female, then average the age. So we've already looked at that average age of the males and the females. Those should be the same that we calculated before. But we've now got the average age of people with light hair, people with dark hair, people with red hair, and then each of those individual points. When we calculate descriptive statistics, do you remember the measure of variability that goes with the mean or the average? Whenever we calculate an average, we also calculate a Standard deviation. Right. So the mean and the standard deviation go together. Unfortunately, Excel doesn't have a conditional standard deviation function. And so that's going to be difficult for us to calculate in Excel. And this is the point at which you'd be moving on to a statistics program. You're getting so ready to tackle those statistics programs. So we're not going to bother calculating the standard deviation of these averages, but be aware that that's what we would be calculating. And then that would also allow us to calculate the standard error of the mean. How would we visualize this data? We've got a continuous outcome. We've got two categorical predictors. That's sounding like another clustered column to me. What decision are you going to make about clustering the data? Again, are you going to cluster it by male and female and then show their average age? Or are you going to cluster it by hair color and compare the males to the females? Let me move that legend to the right. When we have it organized this way, we can see the overall pattern that females win the award younger than males. We can also see that the difference between the ages for those with light hair looks very similar to the difference between the ages for those with dark hair. Do you remember when we were looking at those patterns before and we were saying that if it looks the same, if the pattern looks the same at the different levels of this variable, then we'd say that that was an additive effect. And that if the patterns look different, then we'd be leaning towards an interaction. Let's talk a little bit more about interpreting those main effects and interactions. So we'd be relying on a statistical analysis to tell us if any of these differences that we see are real differences. And again, we'd be getting that probability value. The p is less than 0.05 would tell us that it's likely it is a real difference. P greater than 0.05, it's likely not a real difference. Well, there's no evidence that it is a real difference. To consider the main effects, we'd be comparing those overall averages and we'd be asking, is 44.5 different from 38.8, different from 36.75? So we'd look at the overall difference between the light hair and the dark hair and the red hair and be able to answer which of those is different from each other. And then we'd be looking at the male and the female and asking, is there a main effect of gender? Do the males win the award older than the females? Is that a real difference? And then to ask if it's an interaction or an additive effect, we'd be looking at all 6 of these cells. And we look to see if that pattern is the same or is different. And here we would be concluding that the pattern is the same for the light hair as it is for the dark hair. Just as a reminder of what an interaction does look like, let's go back to that deaths from any cause by duty and rank from the Civil War. And so in this case, we see that the difference between the light blue and the dark blue bar within the infantry is really different from the difference between the light blue bar and the dark blue bar within the non-infantry. And so we can see that that pattern is different between those two groups. That is an interaction, whereas this pattern is the same between the two groups. There really isn't an interaction.